Alright, in this video we're going to introduce rotation of axes. So rotating the x and y axes all together, and it'll help us rotate our graphs. So we're going to look at rotating a point in the coordinate plane, and then in the next video we're going to look at converting an equation to rotated form. So normally in the coordinate plane, each point has both an x and y coordinate or a polar representation of r and then the angle of rotation, which here you can use alpha or whatever you'd like to use, so that the point makes an angle alpha with the x-axis. Now suppose we rotate the axes through the origin at an angle of theta. So we take our axes and we rotate them theta radians or degrees about the origin, and that's going to take our original point that has the value of r as and then an angle of rotation alpha, and now it's rotated in this case even more. So from the x prime and y prime axes perspective, so the red axes perspective, the point x prime y prime has polar coordinates r cosine alpha and r sine alpha. So if we look at the red axes perspective, then the point has what the original perspective had, an x coordinate of r cosine alpha and a y coordinate of r sine alpha. However, from our original axes perspective, now our point has rotated more than alpha, so it has theta plus alpha for the original x and y axes in solid black from the original coordinates. So we have x is going to be r cosine theta plus alpha, and y is going to be r sine theta plus alpha. So expanding each of these using our angle sum identities for cosine and sine, our angle sum identity for cosine is going to be r times the cosine of the first angle times the cosine of the second angle. So r times cosine theta cosine alpha minus r times the sine of the first angle times the sine of the second angle, or minus r sine theta sine alpha. Now if you'll notice in this line, I've color-coded r cosine alpha in red and r sine alpha in blue, because r cosine alpha in red is x prime, and r sine of alpha in blue is y prime. So x prime is going to be r cosine alpha, y prime is going to be r sine alpha. So we have our x coordinate is x prime cosine theta minus y prime sine theta. And expanding the y as r sine theta plus alpha, expanding out our angle sum for sine, we have r times sine of theta times the cosine of alpha plus r times the sine of alpha times the cosine of theta, using our angle sum identity for sine. And once again, we have r cosine alpha in red, r sine alpha in blue. R cosine alpha is x prime, and r sine alpha is y prime. So we have our y coordinate is x prime sine theta plus y prime cosine theta. So putting those two coordinates together for our x and our y for our new rotated point, x prime cosine theta minus y prime sine theta, that gives us our x coordinate. X prime sine theta plus y prime cosine theta gives us our y coordinate. Again, these are just applying the angle sum identities for sine and for cosine. Now, if we want to solve for x prime and y prime, then we have x prime is x cosine theta plus y sine theta, and y prime is negative x sine theta plus y cosine theta. And how we get those cases for x prime and y prime is we replace our theta with negative theta. So we have r cosine alpha minus theta, and y prime is r sine alpha minus theta, and then we expand out. So also note, if you've had some work with matrices in the past, that the matrix representations of x, y, and x prime, y prime are going to be below. So if we have x, y, we can multiply our x prime and y prime by cosine theta, negative sine theta, cosine theta, And likewise for finding x prime and y prime, we can multiply our x and y coordinates by cosine theta, the matrix represented by cosine theta, sine theta, negative sine theta, cosine theta. Again, this is if you've had work with matrices and matrix multiplication. This is the matrix representation, which condenses it down a little bit. But if you haven't had that, you don't have to worry. All right, example 1. Suppose the x and y axes are rotated counterclockwise through an angle of theta equals pi over 3 to give us our new x prime and y prime axes. So let's say we had an original point of 2, negative 4. We want to find if we rotate that point 60 degrees counterclockwise about the origin, what are the new coordinates going to be? So our new x coordinate is going to be our old x coordinate times the cosine of the angle plus the old y coordinate times the sine of the angle. So x prime is going to be our original x coordinate is 2 times the cosine of pi over 3. And plus our original y coordinate is negative 4 times the sine of pi over 3. And when we simplify that, 2 times the cosine of pi over 3 is 1. Negative 4 times the sine of pi over 3 is negative 2 square root of 3. So our new x coordinate is going to be 1 minus 2 times the square root of 3 when we rotate this point pi over 3 radians about the origin. To find our new y coordinate, it's our negative of our old x coordinate times the sine of the angle plus our old y coordinate times the cosine of the angle. So our old x coordinate, the opposite of it, is negative 2 times the sine of pi over 3 plus our old y coordinate of negative 4 times the cosine of pi over 3. And when we simplify that, negative 2 sine of pi over 3 gives us negative square root of 3. And negative 4 times the cosine of pi over 3 gives us negative 2. So our new point is going to have the coordinates 1 minus 2 square root of 3 and negative 2 minus the square root of 3. So again, all we're doing is taking this point and rotating it 60 degrees or pi over 3 radians counterclockwise to get these new points as well. All right, that about does it for this video. In the next video, we're going to look at example 1b, which involves taking an entire equation and rotating it by pi over 3 radians. So I'll see you then.